Hello everyone, welcome to the Study Hacks Institute of GIS and Remote Sensing. So basically today is our sixth number of class. Okay, and anyone who want to join my online training program, you can easily register with my online training program, and you can easily join with me live training session. Okay, so now this session is open for the 7 days online training program for Google Earth Engine for remote sensing analysis, and this new batch class will be start from the 10th March, and animation last is the 5th March. Okay, and first 5 registered people get the 50% discount. Okay, so for getting this discount, you have to register as soon as possible. Okay, and you can easily contact with me this WhatsApp number, and so also give me email for get all of the information for registration. So basically in this online training program we are cover all of the things from beginners to advanced level. So if you don't know, have any knowledge about the programming or any knowledge about the remote sensing or Google Earth Engine platform, I hope you can easily understand all of the things. Okay, so these are full course content, and you can also get the some course certificate, materials, practice code, recorded video class, and lifetime teaching support. Okay, so if you want to join my online training program, you can easily contact with me this email, and also WhatsApp number, and also complete your registration and join our online training program. Okay, so thank you. Okay, so hello everyone, welcome. Can you hear me? Hello. Hello, can you hear me?
Hello, yes, we can hear you.
Okay, thank you. Okay. Okay, so we are waiting for 1 or 2 minutes, then continue
You
our
are
today's
unaudible,
class.
sir.
Yeah.
You are unaudible.
Okay. Okay, so for joining all of the participants, we can just waiting for 1 minute or 2 minutes, then we will start our today's class. Okay, so now we will start our today's class. So basically, today is our sixth number of class. Today we will try to discuss about that land use and land cover classification map. So I will try to discuss about the all of the techniques for land use land cover classification map. So I hope you can easily understand about all of the things. Okay, so now we will start our today's class. So I simply share my screen. Okay, so now can you see my screen?
Yes, we can see it.
Okay. Okay, so I simply open my share screen slide. So hi and welcome to the 7 days online training program on Google Earth Engine for remote sensing analysis, beginners to advanced level. So we already covered our lot of part, and today we will try to mainly focus on land use, land cover classification. How you can easily use using the different types of machine learning for making the land use land cover classification map, and then how you can easily make the classification chart. In this time we can easily calculate all of the area, and we can easily make the chart all of the area, and also calculating the LULC classification. How you can easily add the legend, okay, as well as we also try to complete the part how you can easily make the accuracy assessment of your map, and how you can easily add the legend title on your map. Okay, so basically all of the things we'll try to complete it for today's class. And next class we also try to discuss about the change detection for the different time period. What is the change and how you can easily calculate the transition area for different time period. Okay, so let's go. So first of all, when you want to make the land use land cover classification map in Google Earth Engine platform, we have to follow some step, and this step or process is the same when you want to use the Landsat image or Sentinel image. You can just follow the same process. I hope you can easily make the land use land cover classification map in Google Earth Engine platform. So first step is that I think some person also try to join. Just let's simply access and continue. Okay. So first of all, first step is that you have to selecting your ROI. Suppose you want to make the land use land cover classification map for region of Dhaka city. So you can simply import your boundary shapefile of Dhaka city. So this is our first step. Which area you want to need, you can simply import your boundary shapefile. Then you have to choosing and filtering the image collection. So in this time, if you want, you can choose the Landsat image. If you want, you can choose the Sentinel image. There is no difference. You can choose any image. And then you have to filter the image collection. So you already discussed about the filtering the image collection, how you can easily filter the image collection for different time period, how you can easily filter the image collection using the image metadata. So you need to filter the image collection. Then you have to collecting the training point. Okay, in this time we are using here the supervised machine learning method, so that's why we also need to add here the some training point. Okay, suppose you want to make the classification for the water body, cropland or build up area, vegetation, then you have to collect some training point according to your classes. After that you need to merge all of the training point. So you need to merge all of the training point together and make a one collection. Okay, and then you need to make a training data set by sample regions. So in this time, this training data set is the combination of band pixel value. Okay, so you have to select some specific band. So all of the training point collect some pixel value and make a training data set. Okay, and this training data set we can classify using the classifier. So for that we need to use the classifier. So Google Earth Engine has a lot of classifier is already available, and this classifier is the built-in already. It's built in here. So random forest as well as also classification regression trees, minimum distance. So you can just use this classifier and classify the image. After that you need to create the classified image and display the image, and then you need to make the confusion matrix for accuracy assessment. So in this time, for calculating the accuracy assessment, we have also need to another ground truth data. Suppose you can simply go to the field and also take the GPS location on this field, and from this field you can easily put the point as a ground truth. Okay, so I'll also try to show you that how you can easily do that, you can easily understand about that. how we can easily make the confusion matrix, and from the confusion matrix we can easily calculate the different types of accuracy such as producer accuracy, consumer accuracy, then kappa coefficient. All of the accuracy we can easily calculate it from the confusion matrix. And also and then we also need to calculate the area for each classes, how much cropland, how much vegetation, how much barren land, how much build-up area is available. We can easily calculate it. Okay, so you can see this is the process when you want to make the any types of land use land cover classification map using the Google Earth Engine platform. We follow step by step, then we can easily create it, the land use land cover classification map. So first of all, okay, so I simply open my code editor and try to show all of the things practically, then it's better. So I simply open a new code editor. Okay, so first of all, I need to define my area, which area I want to need for land use land cover classification map. So in this time I already imported my boundary shape file in here. So just I simply import the boundary shape file in my code editor and simply open this code editor. So I simply use this Dhaka city boundary shape file. I can simply change the name such as ROI. So this is my region of interest. I want to display the result. I simply use at the map dot add layer and call the object name is the ROI, and also center focus of the shape file. I simply use at the map dot center object ROI. So in this time you can see what happened. I click to the run, then I can get my region of interest. So I want to need the land use land cover classification map for this region. So this is my first step is done. In this time, second step. So in this time you have to choose and filter the image collection. If you want, you can use the Sentinel, or if you want, you can also use at the Landsat. Okay, so in this time I just use at the Landsat image collection. I simply click on the browse data catalog and you can see Landsat. Okay, so here you can see Landsat 9. So which area you want, which time period you want to need, you can simply select this image. So I use the Landsat 8. And then you can see top of atmospheric surface reflectance. I want to use here the surface reflectance satellite image. So now you can see we can get all of the information about the image collection. So in this time I just simply import the image snippet in my code editor. For that, simply copy, and here I can get all of the information. You can see SRB1, SRB2. So in this time I use this, simply copy and paste here, and take a variable name such as L8. You can use any name. In this time, this is my image collection. Okay, I choose this image collection, and then I need to filter. So for the filtering, we already know about the filtering process. I simply take a variable such as image. Okay, and then call my image collection is the L8, because this variable L8 is stored the all of the image collection for the Landsat 8 surface reflectance. I simply use at the filter bounds function with my region of interest, and then I use at the filter date. I simply put this as year of 2020, 1st January from year of 2020, December 31. And then I simply filter metadata and select this cloud cover less than 1. Okay, so in this time I simply filter my image collection according to my region, according to the image metadata, according to the specific time period. Okay, so in this time I want to create the median composite and then make the classification. Or if you want, you can also use the single image and also make the classification. Same process. Okay, so I simply use at the median for this classification, and also clip with my shapefile such as ROI. and then display the result. I simply use the map.add layer, and then call the object name is the image and click on the run. So now I can see display the result. Okay, so you can say I can get the result look like this. So in this time I had the visualization parameter from here. I use here the such as red band, then green band, and blue band. Increase 8%, then apply. Okay, so now I can say I can get this image look like this, and I import the visualization in my code editor. So just simply import, and then simply copy the variable name and paste after the object name. Now it's set it. Okay, so this is my second step. Okay, so filtering and visualizing the satellite images in here. So in this time, third step is that I need to collect some training point, which class I want to need classified. So in this time, from the satellite images, I want to classify the water body, then build-up area, then barren land and vegetation. Okay, so for that I need to create total 4 class training point. Okay, so for collecting the training point, we can use here the different types of band combination for because different types of band combination is useful for identify for the different types of feature. So in this time you can see this band combination is called the true color composition, so or natural color. So natural color, we can easily understand what is the water, what is the vegetation naturally, human, what human eye can see. Okay, so this is the natural color. If you want, you can also use here the another band combination from here. Okay, then we can get the other color. Suppose in this time I use here the band combination, you can see I simply change the band combination such as band 5 in infrared, such as band 4 and band 2, and then 98%, then apply. Okay, so in this time you can see this band combination when you can use, then the water is showing as a black color. Okay, and the vegetation is showing as a red color, dense red color. Okay, so mainly this different types of indices is identify the different types of feature we can easily identify from the satellite images. So when I use this band combination, then it automatically showing the water body as a black color, dense vegetation showing as a dense red color, this type of color. Okay, okay, so when I want to use this such as B6, then B5 and B3 and apply. So now we can easily identify the barren land. Okay, barren land in this time it's showing as a brown color. So this type of land we can easily identify as a brown color is identify the barren land. Okay, and also you can see this is the vegetation you can easily identify. Okay, so different types of band combination we can use for identify the different types of feature on the satellite images. So in this time I want to take the suppose, so it's not any fixed, so you can use here the different types of band combination and collect the get the training point for different types of feature. So in this time suppose I want to use here the B4 and B3 and B2 natural color, and then such as apply. Now it's showing the natural color. So in this time I can collect the training points such as for the collecting training point we can use here this, you can see add a marker. So I want to use this marker for collecting the training point. So for that I simply click on the marker and it's showing the geometry. Okay, then simply click on here and then you can simply put the name. Suppose in this time I take the training point for the water body, just I simply put this water body. Okay, you can use any name as a variable. Then feature collection and property. In this time property name can be anything, you can use any name, and property name is the same for all of the classes. When you want to take the training point for build up area, property name will be same. when you can take the training point for the vegetation, property name will be same. Okay, so in this time I simply put the property name such as class. You can use any name, no problem. And set the value for water body. I simply put the value 0. Okay, so I put here the 0. It not any fixed. If you want, you can use here the 1, 2, 3. There is no problem. But JavaScript programming, it is a 0 base, and 0 refers to the first item. So that's why I simply use it will be start from the 0. And then next class I want to put here the 1. Then next class I put here the 2. Then 3, like this. Okay. Then I simply okay. So I can see it showing the water body in here. Okay. So it will be, I simply select the water body and collect the some training point from here. So you can take the some training point, and when you check the accuracy is not good, then you can also increasing the training point. Okay, there is no problem. And then we can also easily increasing after run our model, we can also easily increasing the training point or decreasing the training point. There is no problem. Okay, so I simply take this training point for the water body. Okay, then I take the another training point such as build up area. Okay, for that click to the new layer and then simply click on here and put this layer name such as build up.
So normally how many training point we should take?
Yeah, please.
Normally how many training point we should take?
It's okay. So I try to so it depend on your region. Suppose when you want to work with the big region, then you can take the training point more than 100. So in this time, Dhaka city is not a big region, so I can simply put this. And when you can check the accuracy, your accuracy is not a good, then you can also need to increasing the training point. Okay.
Okay.
And it's not any fixed for taking the training point. Constant value is not okay. So in this time, simply take the build up and take the census feature collection and property. Set the property name is the same for the class, and I set the value for the build up such as 1, 0, then 1. Okay. So I simply take this training point, and this place we already know better. Okay, so because we live in here, so you can easily understand about the what is the water body, what is the build up area. But when you want to make the land use land cover classification for the unknown place, which place you did not visit physically, then you have to choose the different types of band combination and then try to identify the different types of feature. Okay, so in this time I know very well for this place where the build up area, where the water body, where the vegetation. So that's why I can easily find out this is the water body, this is the vegetation, this is the build up area. But when you want to make the land use land cover classification map for any unknown place, then you have to use the different types of band combination in here and then select the different types of classes.
Sir, can you please try 764 shortwave infrared for visualization?
Okay, actually voice is very low. I did not. Yeah, please again.
Can you please try band combination 764, the shortwave infrared? I think then it will be like much more clear. Maybe you know the place, so it's easy for you to identify the build up or like water. So if
Okay, okay.
use
You
764, I
can
think
you can get a link in here. Just and simply open the link. That's it. And set it. Okay. So from this link, you can get the some more information about that. You can see. You can see this is the 432, red, green, and blue. When you can use the band combination, it is a natural color. What human can, and healthy vegetation is the green, unhealthy vegetation is colored is the brown. Urban feature appear white and gray. What is the dark blue or black? Okay, when you can see 543, near infrared red and green, then we can easily identify. Mainly it used for the analyzing the vegetation, and red have a better vegetation or healthy vegetation. Dark areas are water, urban areas the white. Also can be short wave infrared 764. Then it replicate the, you can see this display the vegetation of the shades of the green. Okay, urban areas are the blue and soils have the various shades of the brown. Agriculture, when you want to identify the agriculture region, then you can use here this 652. then you can we can get this agricultural land. Another is the brown color is showing the fallow land or barren land geological feature. So you can use read this article, then you can easily understand about that. And using these different types of band combination, we can easily classify it, take the training point for the different classes.
Thank you, sir. Thank you.
Okay.
Please, excuse me, can you hear me?
Yeah, please.
Okay, I don't know if the session is recorded because I have class, like I have class 9:30, and I don't know if it's recorded, so that I'll just join my class immediately. Maybe I could listen to it later. So I just want to make sure it's recorded so that you can help me with the file.
Yeah, please. Again, I did not hear you properly. Yeah, please.
Okay, I'm asking if the session is being recorded.
Hello.
Okay, can someone else hear me? Like I'm asking if it's being recorded.
Actually, he's requesting to record the class. Maybe he have to leave, so he need the recording.
Okay.
Right,
Okay.
Matthew?
Yes.
Yeah,
Yes.
yeah. It's
I have class.
yeah, yeah. I recorded the classes. No problem for that. Okay.
Okay. I also wanted to ask, like, for this land use, can I show some like vegetations of the particular area? Like, let me say evergreen forest, the cropland. Is it possible?
Yeah,
Like
it's possible. So when
showing
it,
it?
yeah, it was possible to classify the cropland classification. So anything, any types of classification we can easily do in Google Earth Engine platform, and it is the same process. So mainly when you want to identify the cropland, then we have to know about the ground truth data. So we can simply go to the crop land and take the GPS location, and then this GPS location you have to convert as a shape file or point shape file, then imported the shape file as a training point for the crop field training point. Okay.
Okay. Thank you. I will probably get back to you later.
Okay.
Thank you. I appreciate it. Yeah, bye.
Okay, so in this time I simply take the training point for the build up area. Suppose in this time I take the another class for the vegetation. So simply click on here, geometry, and take the name such as vegetation. Class, and set the value for 0, 1, and then 2. Okay. Suppose in this time I want to use the band combination such as 5, 4, 3. Okay, so I simply select here the 5, 4, and 3. Okay, then apply. So in this time we can get the vegetation as a red color for the or dense red color, identify the vegetation. So in this time I can simply take this vegetation such as, after selecting the vegetation, I simply take the training point for the vegetation such as from this. Okay, then I simply take the another layer such as parallel and take this training point such as feature collection. Class, set the value for 3. Okay, so after that I simply click on OK. And for the barren land, we can use the band convention such as 652. So I simply use here the 652. Six, 5, and 2, and apply. Okay, so now you can easily identify the barren land as a brown color. So for that, I can simply select this barren land and simply take the training point. Okay, so also increasing the barren build-up area by using here this. Okay, then we can merge all of the training point. Okay, so in this time we can say take the training point of the water body, build up, vegetation, and barren land. Okay, so these are our collection point, training point. So in this time I need to merge all of the training point. So for that, simply take a variable such as suppose you can use any variable name. So I simply put the variable name such as training. You can use any variable name. After that, I need to merge all of the training point together. So for that, I simply use the water body. Water body, it merge with build up, also merge with vegetation, and it also merge with parallel. Okay, so I simply merge. In this time, if you want to check how many training point you can total, how many training point you can get, simply print this and simply call this training and click the run. Here I can get total 171 training point. Okay, so you can get the number of the training point. You can see all of the training point I can get in here, and all of the training point has a already you can see for the zero what is the training point. So you can see this training point is for zero. Zero means that what is the class for water. So I take this 0 number training point for water, as well as 26. So what is the training point for this class? You can see 0. So it also, this training point is also for the water. So all of the training point has a categorized. You can see 3. So 131, this training point is for 3 for barren land. Okay, because 0, 1, 2, 3. I set all of the training point value. So 3, all of the 3. This class 3 identify the barren land. So all of the training point for 3 identify the barren land. All of the training point for 2 identify the vegetation. All of the training point for 1 identify the build-up area, and all of the training point for 0 identify the water body training point. Okay, so in this time my main target is that I need to extract the band value, all of the training point. So all of the training point, yeah.
Sir, instead of class, we can write the name of the training point, right? Like suppose it is 0, then we can write class underscore water, or 1 class underscore vegetation. Then it can be good for us, like to understand easily, right?
Okay, so in this time when I want to set the value for the water, you can say I simply put the, okay, sorry, okay, so 0, then it automatically all of the training point, when I want to click on here and take the training point, all of the training point class value is 0.
So can I write the property name as like as a barren land instead of class, changing the class property name?
Okay, I did not get properly.
The way you root the property name, all property name you root class,
Yeah.
right? Not writing the class, can we write for instead of class we can write water or vegetation or build up or barren land, the name directly instead of writing class?
Okay, I think it's not possible because in this time for the class we can only put here the value. Okay.
No, the way you root the class in the property, right?
Yeah.
So without you don't you
Pro-
I just want to know, like, can I write water body instead of class, changing the class? Yeah.
And property name is the same for all of the classes. Water body,
Okay.
built up area.
Okay, I
For
understood. Okay.
yeah, because
I
we need to
understood.
merge. We need to merge. You can see we need to merge all of the
Okay.
training point. Okay. So in this
Okay.
time, when you want to use here the different types of class name, then it not easily merge, and we can get the face the problem. So class, yeah, and when you want to extract the value, then we need to use the property name class. Okay, and it's so that's why it's a unique value. Okay.
Okay, I understand.
Okay. Okay, so in this time, my main target is that I need to extract the band value for all of the training point. So all of the training point, I need to extract the band value, and it's my training data set. And then further, we can train our model using the different types of classifier. So in this time, suppose in this time, I can only use here the internal band, which band is already available in the land set. You can see B1, B2, B3, SRB, all of the band is available in here. But if you want, we can also add here the external band. Suppose you want to create the NDVI as a band, you need to create the NDWI as a band, NEVI as a band. We also need to create. So in this time, when you want to make the further better land use land cover classification map, then we can also add here the different types of external band. Okay. So in this time, I can only use here the band and then try to show you that. So for that, I simply take a variable, put the variable names as band, and then make a list all of the band which band I want to work. So I want to work with the SR, surface reflectance B1, then surface reflectance B2, then use as the surface reflectance B3, then use as the surface reflectance B4, surface reflectance 5, plus a surface reflectance 6, surface reflectance 7. Okay, this band is already available in my satellite images. But if you want, when you want to make the further more advanced land use land cover classification map, then you can also use there some external bands such as NDVI, such as also you can add there the NDWI. So when I use there the NDVI, NDWR or EVI, then all of the training point also extract the NDVI value, NDWI value, EVI value, or which index I want to add. It also extract this band value and run the model. Okay. So in this time, I can simply remove this part. So I take this training point, look like this. In this time, my main target is that all of the training point, I want to extract all of the band value. Suppose you can see for the single, suppose 0 number training point. For the 0 number training point, I need all of the band value. For the, also you can see a 1 number training point, I need the all of the band value. For the 2 number training point, I need the all of the band value. So mainly when you want to extract any band value from the satellite images, then we need to use a function. This function called the reduce sample region. Sorry, sample region. Okay, these are sample regions. This function mainly extract the pixel value. Okay, suppose in this time, this pixel value to be extract when I use the sample regions function. Okay, so let's go. So for that, I can simply take a variable such as, I put the variable name such as training. Okay, I take train image. I take the different variable train image, and then I simply call my image. Which image I want to extract the band pixel value from which image. So I simply call this image because this satellite image is stored in this variable image. Simply copy and then paste here. Okay. After that, I need to select band, which band I want to extract the pixel value. So I simply use the select function, select, and then call the band, all of the band. You can see all of the band is stored in a variable. This variable name is the bands. So I simply copy the variable name and paste here. Okay, and then I use a sample regions. Okay, and put all of the argument one by one. I make a dictionary in here. So curly bracket start and curly bracket. So first of all, collection. So collection is that all of the training point, total 171, and this training point is stored in a variable. This variable name is the training. Simply copy and paste here. Okay, then properties. In this term you can see properties. Properties is that you can see when I want to take the training point for class, you can see property name is the class, but this class is the same for all of the feature. So in this time it as a list, you can see properties. So properties, okay, so properties in this time I need to use here the square bracket and then put here this property name class, because class is not a single. So class is the same for all of the feature. For water body I use the class, for bill of area I use the class, for vegetation I use the class. Okay, so it is a plural form, so that's why I simply use the class. Then scale. Scale is the resolution of your satellite image. So in this time this is 30-meter resolution. For the Landsat I simply put. Okay, then it's not need, I simply remove. In this time I have to print the value of training point. So for that I simply set the print function and then call the training and click to the run. So in this time I can get all of the training point band values. Which band I want to set in here. So here you can see, suppose I want to check the band value for the training number point number 1. You can see here I can get total 8 properties. So all of the band value I can get in here. And what is the class? Class is the 0. Also you can see. So all of the training point we can get the band value. So in this time it's called the training data set. Okay, so in this time this data set I want to use for classify these satellite images. So this data set I can use here the different way. So for that I need to use here the sample region function. Okay, for the sample regions function we can take the training point. In this time this data set I want to use the classifier. Okay, for that I can simply search here classifier. So here you can see different types of classifier is available in here. So you can see, so in this time I simply use the classification irrigation trees. This classifier I want to use. So here I can get it's totally built-in classifier is already available of all of the things in here. So in this time I just use this classifier and then train our model. Okay, and if you want to know the more details about the classification and what all of the argument, how it will be work, so all of the things it are part of our statistical part for the land use land cover classification map. For the statistical part, so in this time I just simply use this. Okay, but it has a lot of equation, lot of things is available because this is a totally statistical term for the classification and irrigation trees. So in this time I can simply use this function. It is a totally built-in function and then train our model. So for that I can simply copy okay, then simply paste it here. Then in this time I simply remove this max node and mean population from here. After that I can simply use this classifier. It's called the classifier, and then train my data set, and this data set is that stored in this variable. For that I can simply use the train function, train. Okay, then you can see I simply all of the argument one by one. For the train I make a dictionary in here, curly bracket start and curly bracket in. Then all of the things I simply put in here, such as feature. So feature is that your data set. In this time data set is the train image. because it stored all of the band pixel value for every single point. I simply copy this variable and paste here. Then class property. So class property is that your class name. You can say I use the class name for the property with the class. In this time you can see it's showing a property, okay, and it's showing the properties. So when I want to get the property, I can simply put this class. I did not use here the square bracket, okay. Then input properties, you can see all of the input properties I stored it in a variable. What is the variable name? Is the band. I can simply copy and paste it. Then I simply one of the things rotated for them. Okay, so it's my classifier. Okay, so in this time I can all of the things I stored in a variable. So for that I can simply put the variable name such as classifier. Okay, you can use any variable name. Okay, so it's our process. You can see in this time. First of all, I again explain. So first of all, I simply take a training, take my ROI or region of interest. After that, I simply filtering and choosing the image collection for the Landsat 8 of surface reflectance, and then take the training point for individual classes. After that, I simply merge all of the training point, and for I also use here the band, which band I want to use, get the training pixel value. So I simply make the list of the band, and from the band I can use here the sample region function for getting the pixel value, okay, and it's my training data set. Further we can use the classification trees and train our model. Okay, so in this time any question you can ask me, any question in here for all of this all of those steps.
Why have you taken this smile card classifier? There are some other classifier also in the list you have shown.
Yeah. So in this time I want to use the classification and regression trees, this classifier, and train my model. Okay, if you want also you can use there the random forest. If you want also you can say never bias, also you can see gradient tree boost, so minimum distance, leaf support vector machine, decision trees. Okay, so all of the classifier has a different types of statistical background. Okay, so you can need,
so in this case we have to take smile card, right?
Yeah, so in this time I want to use here, yeah.
Okay.
Yeah, but if you want to know the more details about all of the things, all of the equation, how it will be work, then this is our another online training program for the statistical part of the land use landmark classification map, because it for the minimum distance for all of the algorithm behind the all of the algorithm has a lot of equation, lot of the term is again you need to when you want to learn all of the things, then I hope you can easily understand about all of the term, and you can easily identify which classifier is the best for you for your research work or other things.
Okay, sir.
Okay.
Thank you.
Okay, so in this time, so suppose you want to use I try to show that again is a random forest. Just simply change it and put here the random forest and train your model. So in this time I just show add this classifier. Now my classifier is the ready. This classifier I want to add with my image.